Good afternoon, students. How are you all? Welcome to one more fabulous session from Infinity Learn. How are you? Mehu Suresh, Faculty of Chemistry from Infinity Learn by Sri Chaitanya. We are conducting NEET Step Up 2025 program. You are all welcome to the session. How are you, my dear students? Hi. So, in this NEET 2025 Step Up program, we successfully completed almost many sessions from last week and last month also, and we are in solutions and colligative properties in grade 12 discussion. So, this NEET 2025 program, we are providing physics, chemistry and biology from afternoon 12 o'clock to evening 6 o'clock, and these sessions are absolutely free. So, and we are giving a chemistry session. My name is Suresh, Faculty of Chemistry. I am providing NEET syllabus for chemistry, and Monday, Tuesday, Wednesday in a week I am discussing 11th standard syllabus, and Thursday, Friday, Saturday I will be discussing 12th standard syllabus. So, in today's session, a 12th standard syllabus. Hi Ishita, hi Nishant, hello, good afternoon. In this 12th standard syllabus, we are with solutions and colligative properties. We already completed solutions and colligative properties and many topics. Now we have to start colligative properties in this part of solutions. So, if you miss concentration terms, classification of solutions and Raoult law, solubility, Henry's law and vapor pressure kind of things, you just watch the recordings of these sessions, right? So, these sessions what we are providing from our end is absolutely free. So, if you follow these lessons in YouTube platform, you are going to prepare your NEET examination. Definitely it will help you to clear NEET, not only clearing NEET but also you can be a topper in that, right? Okay, so we request you just simply like this session and share this session and subscribe to the YouTube channel, right? Yes, Nishant, you want introduction of solutions? And these sessions are especially meant for 12th droppers and who completed 11th standard and stepped into the 12th standard, right? Nishant, you want something else? Introduction? Yes, introduction about the solutions. Definitely we'll do that. No worries. So, today's class of interest करेंगे, आज तैयार है, एक बार थम्स अप देना सेशन में. चार्ट बॉक्स, वेरी गुड. आई एम लुकिंग इनटू द चार्ट बॉक्स and I am giving you. Yes, this is a two-way communication, my dear students. You don't just listen, right? You just also work with me, and today's class undoubtedly you will be getting very good number of questions as well, right? That's good. So, this solutions and colligative properties, or simply you say solutions, right? Okay, you want to show the strength as well. So, types of solutions, it is already done, and you also methods of expression, concentrations. In these types of solutions, you have seen solid solutions, liquid solutions and gaseous solutions, and these three states of matter is combined to give a homogeneous mixture to give rise different varieties of solutions, right? So, in that methods of expression concentration, terms like percentage methods and molarity, molality, mole fraction and ppm kind of things we did it, right? The relation among them also you just gone through that. So, Nishant, you just go through. I am going to anyways try to give a kind of revision in that, but you can go through the revision or recording of the sessions, right? Hi, very good. So, vapor pressure, when a liquid is evaporated, it will condense back. So, the system is at equilibrium, the vapor vapor exert some force on its own liquid at equilibrium at a given temperature. That term is called as vapor pressure, and this is also called as equilibrium vapor pressure, and this vapor pressure are related with Raoult law. It is given, okay. So, in that Raoult law, partial vapor pressure of a liquid component is directly proportional to its mole fraction is given in Raoult law. So, an ideal solution and non-ideal solution also we discussed here. A solution which follow Raoult law is called an ideal solution. If it do not follow, it is a non-ideal solution. If it is not following, it could be deviating, right? It is deviating in the positive side or it is deviating on the negative side. So, that is called positive deviation of Raoult law and negative deviation of Raoult law. Also, we started colligative properties. So, फिलहाल अभी तक कर चुका and we will be planning from now onwards colligative properties and abnormal molecular masses and Van 't Hoff factor. So, today's plan for this class is these 2-3 topics. So, colligative properties, abnormal molecular mass and Van 't Hoff factor. I think colligative properties also completed 1 or 2, but I just want to go for the total revision of colligative properties. अगर आपको क्वेश्चन मिले हैं तो ए चैप्टर से आपका राउल्ट लॉ से आने का संभावना है और कॉलिगेटिव प्रॉपर्टी आने का संभावना है. ये कॉलिगेटिव प्रॉपर्टी एंड वान ट हॉफ फैक्टर रिलेटेड के क्वेश्चन आना ज्यादा प्रोबेबिलिटी भी है. हेलो जय बाबा की. The names I found in this YouTube sessions are looking different. Okay. The other day I have seen the tech savvy kind of things. Anyways, all students are good and are regularly attending. Ishita here, right? So she is one of the regular attendee and undoubtedly I can say that Ishita is going to get very good rank and the other students are joining and the remaining students are watching the recording and they are giving comments in it, right? So that helps the student. You also, thank you Ishita. So you also please watch the recording. If I am teaching all these topics, definitely you will understand. But along with that, if you have any doubt, you rewatch it. Otherwise, you can directly comment in the live session. Otherwise, you can see offline comments also. I am going to personally pursue it and I will tell the appropriate answer in that. I am going to respond to each and every comment that you make it. Fine. So, आगे बढ़ना colligative properties. ठीक है? But you fill blast in chat box so that a two-way communication will be there in this class. Talking about here, so colligative properties. What are colligative properties? So, a liquid solution has certain liquid solution, okay. So, liquid solution have some properties. Certain properties depend on the number of solute particles in the solution, but not on the chemical nature of the solute. Such properties are called colligative properties, that is clearly mentioned there. So, colligative properties दिखने के लिए solution, a solid should be dissolved in a liquid. And I want to say the condition for the colligative property is the solute should be non-volatile. That is very, very important. What is the meaning of a non-volatile solute? Can anybody say what is the meaning of a non-volatile solute? फटाफट बोलना यार, जल्दी जल्दी बोलना. So a non-volatile solute is a solute which do not evaporate, है ना? Right. So there are 4 colligative properties. One is a relative lowering of vapor pressure. You can simply say RLVP. And elevation in boiling point of a solution, that is called EBP. And depression in freezing point of the solution, so that is called DFP. And osmotic pressure. My dear students, here एक चीज है, सो रिलेटिव लॉवरिंग ऑफ वेपर प्रेशर कॉलिगेटिव प्रॉपर्टी होगा, लेकिन लोअरिंग ऑफ वेपर प्रेशर, खाली लोअरिंग ऑफ वेपर प्रेशर कॉलिगेटिव प्रॉपर्टी नहीं होगा. सो एलिवेशन का मतलब क्या, increase in the boiling point is colligative property, but boiling property alone is not a colligative property. Depression in the freezing point is a colligative property, but freezing point is not a colligative property. Osmotic pressure is a colligative property, लेकिन osmosis is not a colligative property. It's a very important. Which of the following is not a colligative property? Which of the following is a colligative property? ऐसे तरीके क्वेश्चंस नीट में पूछा जाएंगे आपका. very important. Okay, so there are only 4 colligative properties बेटा. ठीक है, colligative properties are generally used to determine the molecular mass of the solute. So ये 4 colligative properties पढ़ाने के बाद आपको क्या मिलेगा, जो सोल्यूट है ना, अननोन सोल्यूट, ये अननोन सोल्यूट का मॉलिक्यूलर मास निकालने के लिए आप इस्तेमाल कर सकते हैं. ठीक है, इट्स अ वेरी इंपॉर्टेंट कॉन्सेप्ट, राइट. सो आगे बढ़ना, कॉलिगेटिव प्रॉपर्टीज, रिलेटिव लॉवरिंग ऑफ वेपर प्रेशर पहले. सो यू कैन सी ए प्योर लिक्विड, दिस इज योर प्योर लिक्विड. ये प्योर लिक्विड का जो है द वेपर प्रेशर जो इतना वेपर से, so that is what you call it is a P naught, and if you add a non-volatile solute to it, so there is a decrease in the vapor pressure, so this is what you call it as a PS, right. So the decrease in the vapor pressure, you can say lowering of vapor pressure, it is equal to P naught minus PS. So there is a decrease in, decrease means lowering. So decrease. सिकंदर मेहता, गुड इवनिंग नहीं बेटा, गुड आफ्टरनून बोलो. ओके, सो हेलो हर्षित शर्मा. सो किसका रिलेटिव का, सो रिलेटिव लोअरिंग ऑफ वेपर प्रेशर आता है P नॉट माइनस PS अपॉन P नॉट. P नॉट का रिलेटिव में लोअरिंग होगा. ओके, दिस इज व्हाट यू का. अरहान दार, hello, yesterday you didn't come to the class, why? Arhan, I was actually waiting for you in everyday's class. Harshit Sharma, hello, very good. हाँ, कोई बात नहीं मेहता, कोई बात नहीं. Okay, so this is actually equal to relative lowering of vapor pressure is equal to P naught minus PS upon P naught is equal to mole fraction of solute. बस मोल फ्रैक्शन ऑफ सोल्यूट. एक ही फॉर्मूला है, ज्यादा कर सकता है एक ही फॉर्मूला से आप. हाँ, इससे और ना जाए, ज्यादा चाहिए. दैट्स गुड, वेरी गुड, नाइस. That is given as relative lowering of vapor pressure. The relative lowering of vapor pressure, it is actually given as these slides are given as a notes, and सारा के सारा ये slides आपका PDF में convert करके आपका Telegram channel में भेजना है. So you can download those PDF notes and you can make a great notes of it directly connected to the NEET. That's why, my dear students, please join in the Telegram channel that is given in the comment section and the description channel, right? You all getting the notes? Ishita, are you getting the notes? Are you getting the notes? Okay, right. So vapor pressure of the solvent in the solution is less than that of the pure solvent. So the lowering or decrease in the vapor pressure is indicated by P naught minus PS. So PS is equal to P naught is dot mole fraction of the solvent. Here 1 is a solvent, 2 is a solute. Okay, delta P means, my dear students, it is equal to P naught minus PS, lowering of vapor pressure. So that it is P naught minus P naught mole fraction of 1, that is P naught common K 1 minus mole fraction of 1 is written. So based on that you can take a direct formula from here this is. Okay, X2 means solute. 1 is solvent and 2 is solute, right? So, P naught delta P upon P naught, this is called relative lowering of vapor pressure. This relative lowering of vapor pressure is equal to mole fraction of the solute. Richa Sharma, good afternoon. And that is equal to P naught minus Ps upon P naught is equal to mole fraction of the solute. Mole fraction of the solute, you can say simply number of moles of solute upon number of moles of solute plus number of moles of solvent. Richa, you are late. Okay, you can directly use this formula. You can use this formula because you can ignore this value, because for a very dilute solution number of moles of solute कम से कम होगा, इसका वैल्यू जैसे you can ignore कर सकते हैं. So that we can write P naught minus Ps is equal to N solute upon N solvent, ये ignore करके. So N solute means weight of solute upon molecular weight of solute into N solvent, ये ऊपर जाके molecular weight of solvent upon molecular weight of solvent, weight of solvent, right? So yes, Richa. Okay, no other personal discussions in the class, my dear students. Okay, Harshit, Richa, come on, let us participate in the regular class. So in other simple way, my dear students, you don't have to worry about that. You don't have to worry about that. I just want to give you a simplified version of the formulas here. You can see. Right, A is solvent, इसे आप ख्याल में रखो. B is solute, है ना. Relative lowering of vapor pressure means P naught minus Ps upon P naught, right, is equal to mole fraction of the solute. Bus, this is actual formula. So based on this you will get so many numericals, my dear. Harshit Sharma. Okay, I said Harshit Sharma, so don't discuss anything about okay. Richa Sharma and Harshit, you please participate in the chat box, but not with the other discussion. You can deliberately use the chat box for academic discussions, right, beta? Otherwise, I will consider this as a spam. Don't talk about anything, okay? Don't mind. Risha, are you with me? So that we can say number of moles of solute upon number of moles of solvent plus number of moles of solute, right? So as this value is too small, I just want to ignore this, because yes, you are a good student, I know that. Every student in this class is a good student. So that P naught Ps and P naught is equal to NB upon Na bus. What is NB? Weight B upon molecular weight B. You can say this one as P naught minus Ps. P naught is equal to NB is written as weight of B, molecular weight of B, into Na is written as molecular weight of A upon weight of A bus. So if you have this particular formula, you can calculate the molecular mass. How? You can say molecular weight of the solute can be calculated. This has to be calculated. Are you getting or not? So based on this you can get n number of questions in the NEET examination. So आगे बढ़ो. Now here it is. Another one, elevation and boiling point. What is this elevation and boiling point? So when you take a water, pure water, what temperature it boils? Yes, it boils at what temperature? Pure water, at what temperature it is going to boil? Jaldi, it boils at 100 degree centigrade. उसमें थोड़ा नमक डालना है. Now it is going to boil at 105 degree centigrade. So when something is added in a solution, its boiling point is going to be increased. So that increased, so that is called elevation in the boiling point, right? So that is also a colligative property. How it is? Let us say a graph. I just want to take a graph. Let us say boiling point and vapor pressure graph. So vapor pressure and the temperature, right? When you use a pure solvent, its boiling point is going to be like this, pure solvent ka. If you take a solution का boiling point, solution का vapor pressure solvent से कम होगा और ज़्यादा होगा बोलो. If a non-volatile solute is added, it is going to decrease its vapor pressure, right? This is a solution का. जब आपका vapor pressure 1 atm होता है, I mean to say this equal to atmospheric pressure. When the vapor pressure is equal to atmospheric pressure, then the solution is going to boil at that temperature. So you just take this particular, this is the vapor pressure temperature. So that is temperature boiling for the solvent, and this is the temperature and the temperature boiling for the solution. Okay, that is for solution. जो अंतर है ना, the difference between these two is going to be elevation in boiling point. Is that clear? That is what you call it as elevation in boiling point. You have to understand this graph, this colorful graph like that, right? So elevation in boiling point is directly proportional to molality. M stands for molality. Yes, very good. What is molality, Richa Sharma? Okay, it is a method of concentration term and number of moles of solute. One number of moles of solute present in a kg of solvent is called as molality. So delta TB is equal to Kb into molality. So this is also completed in the previous class, right? So what is Kb? Can somebody tell me what is Kb? ये Kb होता है क्या? That is called molal boiling point constant. अलग अलग नाम भी है इसका, मोलाल एलिवेशन कांस्टेंट. और क्या बोल सकते हैं? इबुलियोस्कोपिक कांस्टेंट. It is what you call ebullioscopic constant. So many names are there. That I just want. Molal boiling point constant. Richa Sharma, you said is correct. So let's go ahead. So that discussion is made here. The same graph is, this is a colorful graph for you. I am just drawing for you, right? Any doubt? Any doubt? Okay, let's go ahead. So this particular molal elevation constant, you have Kb. Okay, that Kb is calculated by using thermodynamics. So thermodynamics term, according to thermodynamics, so this is how a molecular weight is also calculated. Delta Tb is equal to Kb into W2 upon M2 into 1000 by W1. Here delta Tb is the difference between this is your delta Tb, right? So this is your delta Tb. So delta Tb is the difference between these two values. So delta Tb, I would say Tbs minus Tb naught. है ना? That's what it is said, right? No doubt. Thank you, Ishita. Very good. Here So delta TB is given, delta TB is equal to TB minus TB naught is equal to KB molar elevation constant or ebullioscopic constant into its molality. ये molality formula थोड़ा expand करके लिख दिया मैं. Understand? So W2 ये क्या? Weight of solute and M2 ये क्या? That is molecular weight of solute and W1 weight of solvent in grams. Are you clear with this formula? By using this particular formula, my dear students, you can calculate M2 molecular weight of solute. I was keep on telling ये जो colligative property किस चीज के लिए आप इस्तेमाल कर सकते हैं. So colligative properties are generally used to determine the molecular mass of non-volatile solute. Here we use the colligative properties, relative lowering of vapor pressure, and discussed molecular weight of solute and elevation in boiling point. We discussed we can calculate the molecular weight of the solute again here. So that's good, very nice. And आगे जो colligative property ये क्या? आप बोलना आगे जो क्या colligative property क्या हो सकते हैं? चलो आगे जो colligative property का नाम क्या? So I'm asking my dear students, you tell me. Okay, very good, nice. That is depression in freezing point. Okay, और एक चीज है, ebullioscopic constant can be calculated by using thermodynamic formula. That is given as Kb is equal to RTB square upon 1000 LV or is equal to MRTB square by 1000 delta H vap. Here LV stands here latent heat of vaporization, or delta H vap is equal to enthalpy of vaporization. Okay, Tanu, so you kept quiet. How do I recognize that you are Tanu? Depression and freezing point आगे अगले वाले आने colligative property आप सही बोला. ईशिता भी. Okay, R is a gas constant 8.314 and TB square. So this is the boiling point of pure solvent. So I just want to let you know Kb is ebullioscopic constant or molar elevation constant is a constant when 1 mole of solute is taken. So elevation in boiling point is known as Kb. In this Kb, this Kb is the property of solvent. A solution का है नहीं, solvent का. So Risha, you said correct. So this particular formula, खाली formula important है, खाली formula important है, उसमें कुछ numerical नहीं आएगा. ठीक है बेटा, एक बार स्नैपशॉट लिखो जल्दी फटाफट. Now depression in freezing point. A freezing point, what is a freezing point? Freezing point is a temperature where vapor pressure of the solid and liquid is going to be equal. So depression and freezing point. Depression and freezing point means water freezes at 0 degrees centigrade, right? If you add some salt in it, water freezes at near about -3 degrees centigrade, -5 degrees centigrade, like that. So there is a decrease in the vapor pressure. So that is called depression in freezing point or decrease in freezing point. So the depression in freezing point, that is explained by using a graph here. Look at here, a graph, vapor pressure and the temperature. So the vapor pressure increases as temperature increases, but it falls down. So this point of transition From here to here it is a liquid in state, and here it is in the solid in state. This is the point where liquid is converted into a solid. So this is called freezing point. Are you getting or not? This is a solvent. This is a solvent. So from this point, vapor pressure suddenly decrease. If you add some solute in it, ऐसे आपका आएगा, so the solute also, so that it becomes solution. It is going to freeze at this point. ठीक है? Now you can see this is the temperature that is called temperature of a freezing for the solvent. This is what you call it as temperature for the freezing of solution, है ना? And ये दोनों को बीच में जो अंतर है ना, depression in freezing point. So this depression in freezing point is equal to Tf naught minus Tfs. Previous one, solution minus a solvent, freezing, it is solvent minus solution. Got it? Fine. Okay. So depression in freezing point is equal to, is proportional to, फिर भी molality है. So delta Tf is equal to Kf into molality. What is Kf? Kf, Richa, tell me what is Kf? Okay, Richa Sharma, very good. Kf क्या बोले आपको? Kf is called, आप बोलना, आपका जैसे Kb का जैसा होता है, right? It is depression molal, depression constant, molal depression constant. ठीक है? That's good. और एक नाम भी है इशिता, और एक नाम भी है, इसका क्या होगा चिल्ड्रन? इसका क्रायोस्कोपिक कांस्टेंट, क्रायोस्कोपिक कांस्टेंट. Okay, so from here also you can calculate molality and molecular mass, right? So dear students, this much colorful slides, this much great explanation you are getting, so it shouldn't go futile. So आप मेहनत कर रहे हैं, फैकल्टी साइड से हम भी मेहनत कर रहे हैं इन्फिनिटी लर्न स्टूडियो में. So it has to give a proper result, so that अच्छा तरफ अभ्यास करो बेटा, आपका अच्छा होगा, अच्छा सोचो अच्छा होगा. Are you getting or not? Fine. So that please like these sessions and call your friends to join in this session, so that you have to share with them and subscribe with us. So these are absolutely free, you need not have to pay for it, right? But you will get a result out of it. You are all with me? Thumbs up देना, fiery emoji डालो chat box में जल्दी. Fine, great. Okay, go ahead with depression and freezing point here. Colligative property, it's a colligative property, the freezing point of substance in the temperature at which the solid and the liquid forms, the liquid are in the equilibrium with each other. Okay, so that freezing point of solution containing non-volatile solid is always less. It is always less. That is, less means its value is decreased. So it is a depression in freezing point, and the decrease is called depression in freezing point. The depression in freezing point of solution is due to lowering in the vapor pressure. That's the reason why. So all colligative properties are related to the vapor pressure. Solvent का vapor pressure है, solution का vapor pressure है. Solution का vapor pressure हमेशा कम होता है. रिचा शर्मा. So unit of Kf, Gaurav, that's what I am discussing here. Okay, depression in freezing point, Kf and Kb units. Okay, so you can get it the same way, the same graphs that I want to show you here. So the units for Kf are degree per molality. Gaurav, is that fine? Is that fine? Or degree means Kelvin per molality. or Kelvin kg mole inverse. Is that fine? Gaurav, it's a good question. That's good. Timely question. That kind of questions I really appreciate in the middle of the class. Okay, Gaurav, are you regularly attending in the class? No. Okay, it's my pleasure to give answer for any question better. Right? That's very important. Kelvin kg mole inverse. That Kf value depends only upon the nature of solution. फिर भी Kb, Kf both have the constants. They depend on only solvent but not the solute and solution. Right? Right. So thermodynamically also we can calculate. This is मोलालिटी थोड़ा सा एक्सपेंड करके लिखा हुआ, ये सीधा ये फॉर्मूला आपका चीट शीट में बनाना है. So M2 is the molecular mass of the solute. You can calculate. Paul, Sanatan Paul, yes, degree centigrade per mole. You can see डिग्रीज जो है यहां पर केल्विन इस्तेमाल कर सकते हैं, डिग्री सेंटीग्रेड इस्तेमाल कर सकते हैं. ओके, सनातन पॉल, यू सेड करेक्ट. दैट्स गुड डिस्कशन. दैट्स ए गुड डिस्कशन. आई अप्रिशिएट इट. नाउ KF thermodynamically it is given as RTF square upon 1000 LF, MR TF square upon 1000 HF. Here freezing point of the solvent and enthalpy of fusion, latent heat of fusion, that's it is what is said. Okay. Now enthalpy of fusion per mole, okay, freezing point of liquid, every denomination is given. Any doubt here, my dear children? R value you can take 8.314 if it is an SI unit, otherwise to Kelvin degree. So you don't have to solve any kind of numerical based on these formulas. It is just a formula. Based on this formula you can get theoretical questions, right? That's good. Now osmotic pressure. Yeah, osmotic pressure है क्या? Yeah, it's an interesting thing. It's an interesting thing, my dear students. Osmotic pressure, so it is an osmosis. It is a semi-permeable membrane, and this is a vessel. Two liquids are separated by a semi-permeable membrane. So that a semi-permeable membrane, ये होता है क्या? Semi-permeable membrane is a special membrane which allows only solvent through it but not solute, right? Like animal membrane, and any cell membrane or egg layer, okay, not egg shell, egg layer. So and any kind of animal membrane act as a semi-permeable membrane. In this, a high sugar molecule, sugar solution, and a solvent is taken. So that what happen? Water molecules are going to move from low concentration to high concentration. So movement of solvent from low concentration to high concentration, the process you call it as osmosis. You can see here, this is okay, this is semi-permeable membrane. This is your semi-permeable membrane. You can say it is SPM, semi-permeable membrane, right? Here I just want to take a low concentrated solution. This is a high concentrated solution. So as a result of this, only solvent is going to migrate from low concentration to high concentration, right? So the direction is important. This process you call it as osmosis. This semi-permeable membrane, I just want to discuss about this. Semi-permeable membrane, it could be natural or it could be artificial. It could be natural or artificial. Very, very important. Natural, you all know animal membranes. Okay, and ये artificial हो गया. ये artificial semi permeable membrane का और कुछ example दे सकते हैं आप? दे सकते हैं? I would be very happy if you give that. हाँ, very good. It is copper ferrocyanide. This is the compound is used as a artificial semi permeable membrane. आपका नीट में पूछा जाएगा. Got it? Fine. NEET में which of the following compound can be used as artificial semi permeable membrane? Are you getting or not? Clear? है ना? Fine. Very good. That's good. So let's see. Here let us talk about osmotic pressure. The membrane which allows only the molecules of solvent to pass through the but not the solute molecules is called semi-permeable membrane. It is simply called as SPM, right? So parchment membrane, cellophane paper, pig's bladder and some animal membranes or some inorganic precipitate membrane, copper ferrocyanide I have given ना. इसका molecular formula क्या? Cu2 FeCN6. So this act as an artificial semi-permeable membrane, right? So, and the process of solvent flowing into the solution when the solution and solvent are separated by a membrane is called osmosis. In other words, osmosis is the flow of solvent from a dilute solution to concentrated solution. That's what we discussed here, right? So this process you call it an osmosis, right? Now let's get into osmotic pressure. So osmotic pressure हो गया क्या? It's very important. Osmotic pressure is the pressure. You can see a solute. देखो ये solute. Yes, solvent is coming now, so that there should be opposite force. So the excess opposite force that prevent the inflow of the solvent from low concentration to high concentration. This is what you call it as osmotic pressure. This pressure is called osmotic pressure, and I don't want to confuse you because this is a technical one. And this is what you call hydrostatic pressure. So when this solvent molecule make a collision on the SPM, so from low concentration side, that is called hydrostatic pressure. Assume these are all aqueous solutions, and so there should be a force. There should be a force here. So opposing force भी होना चाहिए. जो opposing force है, that is called osmotic pressure. Clear? So osmotic pressure is causing from high concentration side. समझ में रहे क्या? So the minimum process that must be minimum pressure beta Sanatan Pal, the minimum pressure that must be applied to a solution to help the flow of solvent molecule through semi-permeable membrane, वो भी करेक्ट है, वो भी करेक्ट है बेटा. ठीक है, चलो. Now that's what it is, osmotic pressure. Hydrostatic pressure developed in dilute aqueous solution at equilibrium state due to inflow of water when the solution is separated the water by a semi-permeable membrane is called osmotic pressure. What Sanatan Paul said, correct. Okay, osmosis is also called endosmosis or exosmosis. आगे slides में आपको पता चलेगा. Reverse osmosis, everything I am going to explain it here. So when you talk about, this is a clear diagram I just want to give you. Osmotic pressure, right? So you can see this is a solvent and this is a solution. So otherwise I just want to say, There is a semi-permeable membrane. I just want to make it here. This is a membrane, that is semi-permeable membrane, and this is filled with a solution. This is a filled with a solution here. Solution may be a sugar solution. It is a sugar solution, right? This is a sugar solution, right? Now the entire thing is kept in the water. The entire thing is kept in the water. So when you keep it in the water, water is a pure solvent. It is a water, right? So it is water. Right, and here this is a sugar solution. In this sugar solution, what happens? This is high concentrated and this is low concentrated. As a result of this, the water is going to penetrate into this funnel. Understand? Clear? Fine. So in this was the initial one. Okay. Now it is going to be raise its height from its surface. So this is the height that is raised. है ना? That much rise it made against the gravity, that is called hydrostatic pressure. That is equal to HdG. H is the height of the column, D is the density of the sugar solution, G is the acceleration due to gravity. आपका favorite physics है. Okay, so osmotic pressure is equal to HdG at equilibrium. At equilibrium दोनों बराबर होना चाहिए. Got it? दोनों बराबर होना चाहिए. But there is a scientist called Hoff has given very dilute solution behaves as in ideal gas. So according to this, so ideal gas क्या होना? PV is equal to nRT, right? This is ideal gas. Ideal solution का भी pi V is equal to nRT, right? Pi V is equal to nRT. So pi is equal to osmotic pressure. So pi is equal to n by V RT. N by V RT. समझे? So n by V is equal to molarity or concentration. So pi is equal to CRT. ये खतरनाक formula है. So among all colligative properties, osmotic pressure method is the best for calculating molecular mass of unknown solutes, or especially for polymers or proteins or something like that. Why? Because we are conducting this osmotic pressure experiment at room temperature, so that the protein do not denature, the polymer do not denature. Are you getting or not? So this is a very simple method. If you got a question based on this osmotic pressure, you are the luckiest person. है ना? Yes. So that's what it is. So let's talk about the reverse osmosis. That's what is pi is equal to CRT we discussed. C is equal to W by molecular mass and 1 by V into RT. So based on this you can calculate the molecular mass of the solute. It is the best method to calculate. Fine. Osmotic pressure method is used for determining molecular mass of the proteins and polymers and other macromolecules. The reason is we are conducting the experiment at room temperature, and the observations you record here is absolutely, it is more precise. Okay. Now, so what is reverse osmosis? Reverse osmosis. कभी देखा reverse osmosis? Have you ever? हाँ, अभी करेंगे, अभी शुरू करेंगे. सनातन पाल will do it. रिवर्स ऑस्मोसिस जब ऑस्मोटिक प्रेशर एक्सटर्नल प्रेशर अप्लाई करेंगे तो if external pressure is greater than osmotic pressure, reverse osmosis hoga. So this is your fresh water, you can see. So when external pressure is applied more than osmotic pressure, so that this is actually used in getting fresh water from seawater. So the condition for reverse osmosis is, that's very important, P external is greater than pi osmotic pressure, then solvent start moving from high concentration to low concentration, that is the reverse osmosis. इसका condition external pressure इस्तेमाल करना चाहिए. Okay, right. So you have three things: hypertonic solution, isotonic solution, hypotonic solution. उसमें isotonic solution होता है क्या? Isotonic solution जिस solution में osmotic pressure is same. Solution A, let's talk about this is solution A is equal to solution B. That is what you call it as isotonic solution. If it is in the case of RBC, if it is in the case of RBC, if you keep in 0.9% sodium chloride, normal saline, so in these two cases osmotic pressure is the same. Such solutions are called iso-osmotic solutions. NEET 2024 aspirant pain. Okay. Yeah, I agree. Every person who is a NEET. Okay. So let us not talk about pain. We'll just talk about like a farmer, how to raise. Okay. How to raise, Deepika, right? So here osmotic pressure in these two cases will be same, therefore RBC won't be disturbed. That's what is said to be here. Isotonic solution में H2O अंदर जाएंगे, H2O बाहर निकलेंगे. But hypotonic solution, hypo means less, so osmotic pressure of A is less than osmotic pressure of B, that is a hypotonic solution. So that if you take it is RBC, okay, if you place in water, what happens? Osmosis takes place in the reverse way. So exo-osmosis takes place. Exo-osmosis takes place. We are strong. Study term. We are always strong, right? Be strong. Be brave. So जाने दो, आने दो, कोई problem नहीं, रहने दो. Okay. Now let's talk about hypertonic solution. Osmotic pressure of A is greater than osmotic pressure of B. So I just want to say here, RBC is placed in concentrated sugar syrup. So what happened? You are going to see the osmosis takes place outside. In the previous case, osmosis takes place inside. Osmosis takes place inside. That is called endo-osmosis here. Here exo-osmosis takes here. That's what it is indicated. हाँ definitely. आपका नाम क्या बेटा? We are all strong. I like your aspiration, right? In this case, so hypertonic solution, water is coming out, so it is called as exo-osmosis. Here endo-osmosis. This is how, why people, doctors use, you also future you will become a doctor, right Soumya? So my dear doctors, you use isotonic solution for intravenous injections, right? Therefore RBC won't be disturbed. Here if you use hypotonic solution, the solution is going to be bulged, okay? And here hypertonic solution, the cells are going to be wrinkled, right? Okay. Anyways, आइसोटोनिक आरबीसी का आइसोटोनिक कौन कौन होगा? 0.9% सोडियम क्लोराइड इज नॉर्मल सलाइन, और 5% ग्लूकोज, ये दोनों भी आइसोटोनिक होगा आरबीसी के लिए. दैट्स द रीजन वाई when you visit a patient who is having a saline that is injected, it is written as DNS or NS. NS means normal saline, DNS means dextrose normal saline. Got it? Let us talk about some questions. Which of the following is a colligative property? Jaldi bolo. Which of the following is a colligative property? Vapor pressure, boiling point, freezing pressure, osmotic, freezing point, osmotic pressure. Jaldi, I want to see the answer. Chart box, फटाफट. 4, Ishita, absolutely correct. मैं खाली बोला आपका. So osmotic pressure is the colligative property. So vapor pressure itself is not a colligative property. Okay. Soumya, right. Boiling point itself is not a colligative property. It is freezing point is not a colligative property. Now, relative lowering of vapor pressure solution containing 1 mole of urea in 54 grams of water. Oh, wow, wonderful. Who will do that? Who will do that? So, one of my student is asking here, study time, you want to say it is 4, right? No. Okay. So, here, so BC, you want to say BC, Sine, okay, BL, okay, different answers you are giving. So, relative lowering of vapor pressure is equal to mole fraction of the solute, that is number of moles of solute upon number of moles of solvent plus number of moles of solute. Here it is 1 mole of urea is a solute and 54 grams of water. 54 upon 18 is equal to 3, right? 54 upon 18 is equal to 3. So that I just want to say 1 upon 1, 3 plus 1, it is equal to 1 by 4. So मेरा आंसर ऑप्शन 4 होगा. समझ में रहे क्या? समझ में रहे क्या? इशिता, you correct yourself my dear students. Clear? We are doing good questions. Fine. Now और एक क्वेश्चन, relative lowering of vapor pressure is maximum for, अरे किसका है? Relative lowering of vapor pressure maximum, yes, very good. किसका ज्यादा होगा? किसका ज्यादा होगा? Relative lowering of vapor pressure किसका ज्यादा होगा? अरे हर चीज का कैलकुलेट करके बताना है क्या? मैं आपको ये ट्रिक बोलना चाहता हूं, ये ट्रिक, राइट? हाँ, relative lowering of vapor pressure is equal to WB by MB into MA into WA, है ना? So no problem. Okay, look at here, relative lowering of vapor pressure inversely proportional to molecular mass. Okay, relative lowering of vapor pressure inversely proportional to molecular mass. समझ में आ रही क्या? So सबका मोलालिटी सेम है. सो इसका मैक्सिमम किसका होगा? जिस मॉलिक्यूलर मास कम होगा. मॉलिक्यूलर मास ऑफ दिस इज 60, 58.5, Al2SO4 thrice and MgCl2. You calculate molecular mass, you will get the same thing. So Al2SO4 thrice molecular mass is maximum. Okay, इसका relative lowering of vapor pressure भी इसका maximum होगा. Okay, next. The correct order of freezing point of 10 grams of aqueous solution of each urea glucose and sucrose. Yes, in this urea molecular mass of 60, glucose it is 180 and sucrose it is 342, right. Colligative property, freezing point, okay. So as a freezing point, as molecular mass increases, freezing point decreases, so that urea is greater than glucose is greater than sucrose, 60 is less than 180 is less than 342 molecular mass, and freezing point values 60 is greater than 180 is greater than 342. So that I would say urea, glucose and sucrose आपका yes, here you can see again the value of 342, sucrose 180, glucose, urea 60, it follows the same order. Are you getting or not, right? Okay. Now, how many grams of methyl alcohol should be added to 10-liter tank of water to prevent the freezing point at 268? Okay, who is going to give the answer for this? Fine. Jaldi dena. Vikas. Yes. You will you do or you want me to do, my dear students? Yes, look at here. It is going to be like this. Depression in freezing point. That depression in freezing point is given as TF naught minus TFS is equal to KF into molality. For it, molality and molarity is same for dilute solutions. So here 273 is the freezing point of water. You don't have to check it. Minus 268, you can say how many grams freezing point 268 तक पहुंचने के लिए, that is 1.86 value is given as a constant. You have to calculate the weight upon molecular weight of this methyl alcohol is CH3OH. Its molecular mass is 32, okay, in 10 liter of water tank. So if you solve, W is calculated to be 860.2 is coming, so that option 3 you guys are given, Vikas is given, Ishita is given. Fine, understand, clear? That's good. Any doubt in this question, children? Any doubt in this question? Okay, और एक क्वेश्चन तैयार है. Molar depression constant depends on. Who is going to give the answer for this? Who is that? Study time. Okay, Soumya, I think your name is Soumya. Right, that's good. Who is going to give this? Molar depression constant depends on. Solute का property नहीं है. Heat of solution of solvent नहीं है. It nature of the solvent. Okay, it depends on nature of the solvent. It is second answer, right? That's good, my dear children. Now the relation between osmotic pressures P1 at 273 when 10 grams of glucose, 10 grams of urea, 10 grams of sucrose are dissolved in 250 milliliters. You just tell me the answer. You just tell me the answer. You just tell me the answer. What is glucose molecular weight? 180. What is urea molecular mass? 60. Sucrose 342 फिर भी है ना. So that pi is equal to CRT. Pi is equal to CRT. Okay, C is equal to N by VRT. So pi is equal to WB MB 1000 by V in milliliter RT. I just want to say pi and molecular mass are inversely proportional. So molecular mass increases, osmotic pressure decreases. Understand? So molecular mass increases, osmotic pressure decreases. So here 180 and 60, 340. जिसका molecular mass कम हो उसका osmotic pressure ज़्यादा. That's the reason why. You tell me the answer. Option 3 is right. Okay. Sanatan Paul, for you I am discussing these questions better. For you all guys, these many discussions are made. You all enjoying these questions? You all enjoying these questions? Right. Very good. Option 3 is the correct answer for this question. It is given here. Right? That's good. Now let's talk about abnormal molecular mass. Actually, when you use these 4 colligative properties, you calculate molecular mass. Colligative property ka main concept is due for calculating molecular mass. Right? So here when you do so, due to maybe dissociation or maybe association of the solute particles, abnormal colligative properties निकल रहे हैं. So abnormal colligative properties करेक्ट करने के लिए आपका जो चाहिए वांट हॉफ फैक्टर. सो वांट हॉफ फैक्टर इज द रेशियो बिटवीन ऑब्जर्व्ड कॉलिगेटिव प्रॉपर्टी अपॉन कैलकुलेटेड कॉलिगेटिव प्रॉपर्टी. बट हर कॉलिगेटिव प्रॉपर्टी इनवर्सली प्रोपोर्शनल टू मॉलिक्यूलर मास. इसी का कारण व्हाट वी से नॉर्मल मॉलिक्यूलर मास अपॉन एबनॉर्मल मॉलिक्यूलर मास और अदरवाइज कैलकुलेटेड this is better, you can say total number of moles of particles after dissociation or association upon number of moles of particles that are actually taken. Why it is so? I'll give you in a short way. I'll give you, if CH3 COOH is dissolved in water, it is going to be dissociated. So it is going to give CH3 COO minus and H plus. ठीक है? If it is CH3 COOH, if you put in benzene, there is an association. You are going to get CH3 C double bond O OH and here CH3 and C double bond O and OH. ये बीच में हाइड्रोजन बॉन्ड शुरू होगा. So dimerization takes place, association takes place. When association dissociation takes place, number of molecules differs. So number of molecules change, number of particles changed. So number of particles changed, colligative property what you are expected is different from that what you are going to calculate. That's the reason why want half factor is used to correct the given colligative properties. So I'll give you the corrected colligative properties here. Yes. So these are relative lowering of vapor pressure. P naught minus Ps upon P naught is equal to mole fraction of solute. Okay, the mole fraction of solute, and that is multiplied with want half factor. And depression in freezing point delta Tf is equal to IKF molality, or osmotic pressure pi is equal to ICST or CRT. Elevation in boiling point delta TB is equal to IKB molality. So हर colligative properties का concentration terms से you just multiply with want half factor. That is the trick here. अगर no dissociation, no association है, I is equal to 1, non electrolyte का यही condition है. So this is what you call it as non electrolyte. अगर dissociate होगा तो I is equal to greater than 1. If it is association, I is equal to less than 1. So let us talk about here one thing, the degree of dissociation or degree of association. For dissociation, very important, simple trick मैं आपको बताना चाहता हूँ. for dissociation, I mean to say degree of dissociation is alpha. Alpha is equal to I minus 1 upon n minus 1. एक खतरनाक फॉर्मूला है. Okay, so n is the number of particles after dissociation. For association, so I just want to say alpha is equal to, dear children, alpha is equal to I minus 1 by 1 minus 1 by n minus 1. ये दोनों फार्मूला देखने के बराबर देखते लेकिन अलग फार्मूला है. यहाँ पर n माइनस 1 एसोसिएशन के लिए 1 बाई n माइनस 1. समझ में आ रहा है क्या? ठीक है, चलो. नाउ इन दिस केस n is going to be for dimerization, n is equal to 2, trimerization n is equal to 3, tetramerization n is equal to 4, like that. So up to here the concept is clear and the total सारा के सारा concept आपको दे दिया मैं. Okay, right from introduction of the solutions है. So अब थोड़ा सा एक दो questions देखना हम. Okay, चलो. if air is taken ना थोड़ा सा, हाँ ये बोलना, among the following temperature dependent concentration term is, who is going to give? Who is going to give? Yes, finding, yes. You said molality. Okay, I just want to say, my dear students, here temperature. So temperature dependent terms, independent terms. So dependent terms, molarity, normality, weight volume percentage, volume percentage. Here independent में आपका आएगा molality, mole fraction, weight percentage. आपका आंसर है डिपेंडेंट. ऑप्शन 3. नीट में आपका ऐसा सिंपल क्वेश्चंस पूछा जाएगा बेटा. समझ में आ रही क्या? क्लियर, फाइन. रिचा, इट इज ऑप्शन 3 है ना. डिपेंडेंट वाला क्या पूछा मैं, इंडिपेंडेंट वाला क्या नहीं. दैट्स गुड. यू कैन सी ऑप्शन 3, राइट. नाउ लेट अस सी वन मोर. mass volume percentage of 0.1 molar sodium hydroxide. molarity होता, molality है. Actually here molarity is dependent because जिसमें वॉल्यूम टर्म है वो डिपेंड करते हैं, जिसमें वॉल्यूम टर्म नहीं है इंडिपेंडेंट है. ओके, सनातन पॉल, फाइन बेटा, दैट इज सिंपल ट्रिक. ओके, so mass by volume percentage of 0.1 molar sodium hydroxide. 0.1 molar means 0.1 mole of the sodium hydroxide present in 1000 milliliters of the solution. So from here 0.1 mole means, हाँ आप कर सकते हैं. वेरी गुड, आपका आंसर है. So 0.1 molar indicates 0.1 mole solute dissolved in 1000 milliliters. So 0.1 means 5.8 grams, right? So sodium hydroxide now 4 grams. So 4 upon 1000 into 100 is equal to 0.4%. अब जो आंसर दिया ना 0.4%, ऑप्शन 3 is the correct answer. समझ में आ रही क्या बेटा? Very good. Now dear children, in this journey of these solutions on colligative properties, okay, we discussed so many concepts. In this so many concepts, nature of solutions and classification of solutions, सारा के सारा ज़्यादा questions दे दिया आपको, but time is little constraints here. Okay, we discussed about Henry's law, Raoult law, vapor pressure and colligative properties, relative lowering of vapor pressure, and depression in freezing point, elevation in boiling point, and osmotic pressure behave. And at the end, abnormal molecular mass, and we end up with Van 't Hoff factor and a good number of questions, right? So tomorrow we are going to come up with tomorrow. Ravinder, you are there today's class. You can see the recordings also. At the end you are saying tomorrow you are going to hostel, right? Oh, I miss you beta, don't worry. Okay, very good, thank you very much. फिर मिलेंगे tomorrow will with more stuff. I think we start with the arenes, aromatic hydrocarbons tomorrow, right? So see you then, bye bye, see you, God bless you all, bye.